What is the TCP IP model? It's a model to standardize computer networking. Sound familiar? It should, because it's the same description as the OSI model. Now, the OSI model, while widely referenced, isn't used in the real world. The TCP IP model, however, is the real deal. Thankfully, it's not that different. Here is the TCP IP model. 4 simple layers: application, transport, internet, and link. And just like the OSI model, it's numbered from the bottom up, but the direction depends on if you're sending or receiving traffic. So this is the original model, but it has been updated. Here is the brand new, freshly designed model. 1 extra layer and 1 renamed layer. That's it. The link layer has been split into data link and physical, and the internet layer has been renamed the network layer. Simple, right? It gets even better when we compare the TCP IP model to the OSI model. Now, if you remember, the OSI model has 7 layers compared to our 5 here. But when you look at it, you'll notice the application, presentation, and session layers are just shown as application layer in the TCP IP model. All the other layers line up nicely, which is great because we should already know the concept of how this works. So let's remind ourselves about the protocols and devices at each layer. At the application layer, we have application protocols such as HTTP, FTP, and SMTP. The 2 most common transport protocols are TCP and UDP. Port numbers are also added here. At the network layer, we have the Internet Protocol, or IP. Routers also operate at this layer. The data link layer contains Ethernet. Switches typically operate at this layer, although you can get layer 3 switches that have some routing capabilities. Finally, we have the physical layer. Think of everything we can touch and feel here. Things like cables and network interface cards. Okay, so as we send data, each layer will add its own bit of information. This process is called encapsulation. When we hit the physical layer, the data is transmitted over to the receiving device. The receiving device then starts to decapsulate the data. We saw this in the OSI model, but in this video we're going to take a closer look. We start with our application data at layer 5. This is then passed down to the next layer where the transport information is added. Let's say it's a TCP header. Each time a header is added, this will contain specific information. For example, a TCP header will contain things like the source and destination port number, sequence numbers, and a few more bits of information. We'll go over this in more detail in a separate video. We then move to the network layer, where we add the IP header. This will contain the source and destination IP address, as well as some other bits of information. Lastly, we have the data link layer. Here we add not only a header, but a trailer as well. The header contains mainly the destination and source MAC address, and the trailer contains some error checking information that the receiving side can check and make sure the data has been received correctly. Once the data hits the physical layer, it is physically transmitted. So, we've gone through the encapsulation process. It's important to note that at each stage, the data has a specific name. At layer 5, the data is called, well, it's just called data at this stage. Once the transport information has been added, it's now called a segment. Adding the network layer information makes our segment a packet. And finally, once we add our data link information, the packet becomes a frame. Now, once data has been transmitted, the receiving computer decapsulates the information. It will check the destination MAC address for that frame, and if the frame is destined for our computer, it's processed further. The computer then checks the IP information off the packet. Again, if the packet is destined for our computer, it's processed further. The transport information is read and the application data is sent to the receiving application.